Hi guys, good to see you. Mr. Kane here.
Morning, guys. Mrs. G.
Alright, if you're not part of the solution, you're part of the dilution.
You're not part of it. So this is the last...
Wait, that makes no sense.
Yeah, that didn't make sense.
Alright.
That's okay. Most of the things you say doesn't make sense. Not at this hour of the morning, anyway. This is the last section of this unit, correct?
Yep, that's right.
Alright.
Last section, dilutions.
We will...
once you've made up your stock solution,
Yep.
or you have a stock solution, let's say you buy acid, you get it as concentrated.
Right. All our acids come to us as concentrated.
Right. It's cheaper to ship them that way because they're not as heavy. And basically, you have to dilute them down to whatever you want. Because if you want 1 molar hydrochloric acid, it starts out as 12 molar hydrochloric acid.
Well, in all the chemicals we use for AP chemistry, I can't have a storage room of every possible dilution. So I get it. I make a concentrated or stock, and then I have to dilute that down. So this stuff is important.
Right, because you don't always need the most concentrated. In order to dilute a solution, it's exactly like you used to have to do when you got concentrated juice at the store. Often solutions come in that concentrated form, and you need to dilute them down by adding water. The interesting part is there's kind of a law of conservation. The number of moles before is equal to the number of moles after.
Yeah, because you're not adding more concentration. You're not adding more of the solute.
You're adding more solvent.
You're just adding water.
Right, so you're adding water. So we simply add water to increase the volume and decrease the molarity.
And since molarity is equal to moles divided by volume, every time you increase the volume, you're decreasing the molarity.
Right. And you wind up getting a piece of math that looks like this. M1V1 equals M2V2.
Yep, so the molarity of solution number 1 times the volume of solution number 1 is equal to the molarity of solution number 2 times the volume of solution number 2.
Where 1 represents before and 2 represents after, right?
1 represents your concentrated and 2 represents your dilute. You have to be very careful of V2. That V2 is total volume. That's the volume of your concentrate plus however much water you put in.
Right. So
it gets tricky. Be careful.
So sometimes you're asked, what is the final volume? In which case you're solving directly for V2.
Correct. It's just algebra.
But other times you're asked how much water needs to be added, and then you need to find V2 and subtract it from V1 because that'll be how much water you need to add.
Yep, the difference between V2 and V1 will be the amount of water because V1 is the amount of your concentrated solution. Finding the water part takes a little thought, so be careful.
So here's an example. How much concentrated sulfuric acid is needed to prepare 250 mils of a 6 molar solution?
Okay, so let's do a little analysis here, Mr. Kane. Let's see. How much concentrated 18.0 molar? So I'm assuming that's my M1 is 18 molar, correct?
18 molar, that's how much we start with. That's a concentrated, so it's probably M1, yeah. So 18.0 molar for M1.
Okay. Needed to prepare 250 mils of a 6 molar solution. The 250 mils and the 6 molar is the second information.
Okay, so 6 molar. Now, Mrs. G, do I have to use liters or can I use milliliters?
No, you can use milliliters because it's just algebra. Your answer will come out in milliliters. Okay,
so if I use milliliters, I get milliliters.
Correct.
So I'll get, well, apparently I'm trying to find
That's our unknown, right?
V milliliters.
Right, it's 4 variables. They got to give you 3 in the problem. You find that 4th one algebraically.
Okay. So M1V1 equals M2V2, so I take 18.0, multiply it by V, 6.0 times 250. Let's see, we're going to wind up dividing both sides by 18.0 in order to do this, right?
Yep.
So my volume is going to be 6 times 250 divided by 18.
And you get 83.3 with 3 sig figs.
83.3, and the units
milliliters.
Again? Milliliters, because I put milliliters in.
Yep.
So that's how much sulfuric acid I would need to prepare a 6 molar solution.
Right, so you would measure out 83.3 milliliters of the 18 molar concentrated, put it in a container, and then fill it up to 250 mils with water.
Oh, this is kind of like making a stock solution almost.
Hey, how much water is that, Mr. Kane?
How much water is that?
How much water would that be?
So if we were asked how much water is that, we do 250 minus 83.3.
And you would get 167 with the proper number of sig figs.
167
milliliters. 750 mils of a 12 molar solution of HCl has 500 mils of water added to it. What is the new concentration? All right, let's see.
All right, let me write down my variables down here. M1, V1, and M2, V2. All right.
All right, so the 12 molar is the concentrated, so that's the M1.
12.0 molar, got it.
And the 750 ml is the volume of the concentrate.
All right.
They're asking you for the concentration, so M2 is our unknown.
All right, so M, all right.
Now, this is tricky because it says 750 mils of HCl has 500 mils of water added to it. That means that V2...
The final volume isn't 500 then.
Right. The final volume is not 500. It's the sum of the 750 and the 500.
So it's 1250.
Yep.
So we get 1250 milliliters. Okay. So that means that if I'm plugging this all in, it's M1V1 equals M2V2, so it's 12 times 750 is equal to M times 1250, so we're going to divide both sides by 1250. And the molarity we wind up with is going to be
7.20 molar, or moles per liter, or capital M.
7.20 molar solution.
And does that make sense? Well, we went from a 12 molar to a 7.2 molar.
So it went down.
Yeah, it went down. You're diluting it. Not a lot.
It seems like it went down a reasonable amount. It's not quite half, right?
Right. It's not. You didn't cut it in half.
Because if they'd cut it in half, I would have expected it to be 6,
Yeah.
and that would have been 750 milliliters
Right.
added. So not quite 6, but yeah, that seems reasonable. And we're done.
That's it? Oh, easy.